Problem number 2. The diameter of a cylindrical conductor A is 6 mm and its length is 2 meters. The diameter and length of cylindrical B of the same material as A are 3 mm and 1 meter. The resistance of conductor B is 0.2 ohms. Determine the resistance of conductor A, its temperature being the same as that of B. Okay, so our first procedure is to summarize and compare both given. So based on our statement of the problem, we have two different conductor. We have a 2-meter conductor and a 1-meter conductor. Okay, so we need to summarize the given data. So for our conductor A, we have a diameter of 6 mm, 2 meters length, and the resistance is not given. How about for our conductor 2? For our conductor 2 or conductor B, we have a diameter of 3 mm, a length of 1 meter, and a resistance of 0.02 ohms. Therefore, our unknown is the resistance of conductor A. Okay. If we recall, in our previous problem, this is the same. They have the same material as A and of B. Okay, so what does that mean? That the resistivity of conductor 1 is equal to the resistivity of a conductor 2. Again, this is the same. So this is their starting point. So we need to recall the formula for resistance, this resistivity, length over the cross-sectional area. If we transpose this in terms of the resistivity, our resistivity is equal to the resistance times the cross-sectional area over length. So this is our formula that will to be substituted to our condition of our problem. This will be substituted here. Okay, doing so, let's repeat the process. That is for conductor A, cross-sectional area of A all over the length of conductor A is equal to the resistance of B, the cross-sectional area of conductor B all over the length of conductor B. Okay, so we need to check the data. So resistance is unknown, so the given is in diameter, so we have a cross-sectional area. The resistance of conductor B is given, both length are given. Okay, so our unknown is the resistance of conductor A. Again, we need to deal with the cross-sectional area of both conductors. If you recall the formula for a cylindrical conductor, we have 1 port pi d squared. So we use this formula, we substitute it to our equation. Okay, so doing so, let's solve and substitute the given. Okay, so for our conductor A, resistance of conductor A, which is our unknown, the cross-sectional area of conductor A, that is 1 port pi times its diameter, that is 6.0 mm squared, all over the length of 2 meters. On the other side, the resistance is given, so that is 0.02 ohms. The cross-sectional area 1 port pi d squared, that is 3 mm, 3.0 mm squared, all over the length of 1 meter. Okay, so we do cancellation of the units. So cancel meter both sides. The square millimeter will be cancelled. The remaining is 6 squared Here, square millimeter will be cancelled. The remaining is 3 squared. Okay. So the remaining units is in ohms. So that is the unit of our unknown with the resistance of conductor A. Doing the math, the resistance of our conductor A is equal to 0.01 ohms.